Rotational dynamics is 12 physics really chapter 1 rotational dynamics. Mm, Today we are going to learn about rotational dynamics. What is rotational dynamics? Introduction to rotational dynamics. Rotational dynamics is the motion of an object around an axis or center point. It is the rotation of an object around an axis rather than unlike translation motion. Thus, in a straight line, rotational motion involves circular or angular movement rather than linear movement. Definition of rotational motion. When a rigid body moves such that all particles of the body move in a circle around a common axis, the motion is called rotational motion. Means all the particles of a body move in a circle around a common axis. Just like the pedal in our bicycle. A rigid body moves such that all particles of body move in a circle around the common axis. The motion is called rotational motion. The axis about which the body rotates is called the axis of rotation. Importance in daily life. Transportation, wheels of vehicles, propellers of aircrafts, household items, ceiling fans, washing machines, blenders, natural phenomena, Earth's rotation, planetary motion. Sports, cricket balls spin, figure skating spins, etc. And in engineering field also, in turbines, motors and generators. They are very important in our daily life. Understanding motion or rotational dynamics is crucial for analyzing mechanical systems, energy conservation, and angular momentum in various physical phenomena. Now, basic terms and definitions. Angular displacement and velocity and acceleration. What is angular displacement? Angular displacement is denoted by theta. The angle through which a rotating body moves about its axis of rotation. Means a rotating body moves about axis of rotation. That angle theta is called angular displacement. The formula of angular displacement is S divided by R. When S is the arc, and R is the radius or the length, radius of the circle R, and the arc. Theta is the angle through which a rotating body moves with its axis of rotation. Its unit is in radian or degree. 1 radian equal to 57.3 degree. 2 pi radian equal to 360 degree. Now, angular velocity. Definition. The rate of change of angular displacement with respect to time. Formula omega. Angular velocity is denoted by omega. Formula equal to omega is equal to d theta upon dt, or omega equal to del theta upon del t. Change in theta, change in angular displacement upon change in time. In other words, angular velocity can be defined as the ratio in change in angular displacement to the change in time is called angular velocity. Its unit is radian per second, whereas angular displacement unit is radian and time unit is second, so its unit is radian per second by the formula, or the revolution per minute in RPM. Direction determined by right hand rule. It is determined by right hand thumb rule. Angular velocity direction is determined by right hand rule. Angular acceleration. The rate of change of angular velocity with respect to time is known as angular acceleration, denoted by alpha. Formula alpha equal to d omega upon dt. Rate of change of angular velocity is called angular acceleration, or alpha equal to del omega upon del t. Its unit is radian per second square. Angular velocity per unit time. Angular velocity is radian per second. So radian per second per unit time, radian per second square. Types: positive acceleration, negative acceleration, angular acceleration. Key point: these angular quantities are analogous to linear quantities. displacement, velocity, and acceleration, but describe rotational motion instead of translation motion. Angular quantities are analogous to linear quantities, displacement, velocity, and acceleration, but describe rotational motion instead of translation motion. Means they are just like displacement, linear velocity, and linear acceleration, but they describe rotational motion rather than linear motion. Relationship between linear and angular quantities. Linear angular relationships. For a point the distance r from the axis, velocity is equal to r into angular velocity. Omega is angular velocity. Linear velocity is equal to radius into angular velocity. Tangential acceleration equals to radius into angular acceleration. Similarly, centripetal acceleration equal to radius into angular acceleration square. Arc length equal to radius into angular displacement. Arc length equal to radius into angular displacement. Here, there are given quantities and its linear form and in angular form. Displacement in linear form in meters, angular form is radians or theta. Velocity, linear velocity in meter per second, angular velocity omega in radian per second. Acceleration, linear acceleration on acceleration meter per second square, whereas angular acceleration can be given as alpha radian per second square. Okay, this much for today in lecture 1, and in lecture 2 we'll know about what is moment of inertia. So stick with us and subscribe to the channel.